Let's be real, watching your cloud API costs compound every single month is exhausting. But there's a way out. You can absolutely escape the subscription trap by building a high-performance, localized AI workstation right on your desk. And no, you do not need a data center budget to pull it off. We're talking exactly $1,000. That is the budget reality for 2026 if you want to run massive 30 billion parameter models locally without making a single compromise. No API throttling, zero privacy concerns, just your own raw compute power. The foundational secret to pulling this off? As Tim Detmers points out, the most important number for local AI isn't T-flops, it's gigabytes of VRAM. Sourcing a used 24 gigabyte RTX 3090 on the secondary market gives you the exact same memory capacity as a brand new RTX 490, but for around $800. It is quite literally the budget builder's cheat code. So here is the exact sub $1,000 blueprint. Notice how every single component here is strategically selected to serve one master, that massive graphics card. We're keeping the processor, the memory, and the storage incredibly practical so that the vast majority of our budget goes straight into video RAM. Now, you might be wondering, why the RTX 3090? Why does a piece of hardware released years ago completely dominate the 2026 budget landscape over brand new alternatives? Well, it all comes down to the memory bus. When you run an 8 billion parameter model, the 3090 cranks out an incredible 112 tokens per second. That is roughly 3 times the inference speed of newer cards like the 4060 Ti or 5060 Ti. It's all thanks to the 3090's 384-bit memory bus pushing a massive 936 gigabytes per second of bandwidth. But it's not just about speed, right? It's about scale. That extra 8 gigabytes of VRAM physically determines the size of the intelligence you can run natively. 24 gigs gives you the breathing room for heavy fine-tuning and running 30 billion parameter models. Meanwhile, 16 gigs keeps you permanently bottlenecked at the 13 billion parameter tier. It's a huge difference. Okay, so we've got the GPU sorted out, but that brings us to the most critical and honestly, the most frequently overlooked failure point in modern AI builds. Think of it this way. Your VRAM holds the model itself, but your system memory handles literally everything else. When you're pushing a massive 128K context window, storing your KV cache, or relying on your CPU to offload model layers because your VRAM is tapped out, your system RAM is doing the heavy lifting to keep generation from crashing. Because of that, 32 gigabytes is your strict minimum for 2026. This gives you just enough headroom to run basic multi-model workflows, like keeping a coding agent active alongside a chat model while keeping your operating system stable. And now you're probably thinking, why not just throw 64 gigs in there to be safe? Well, we actually can't. The 2026 AI-driven global memory shortage has severely inflated DDR5 prices. A 64-gig kit would run you anywhere from $700 to $900 right now, which completely shatters our $1,000 budget constraint. So what about this supporting cast? What hardware do we actually need to keep this massive GPU fed with data without causing a systemic crash? Since AI inference is almost entirely GPU-bound, a Ryzen 5 7600 handles the CPU workload perfectly. Throw in a fast 1 terabyte NVMe drive so your models load into memory fast, but listen, the power supply, that 850-watt 80-plus gold unit is absolutely non-negotiable. The 3090 is notorious for violent 350-watt power spikes, so skimping on your power supply is a guaranteed ticket to frustrating crashes. Now, I completely get it. Building a discrete PC server isn't for everyone. What if you just want to skip the assembly, ignore Linux drivers, and just start chatting immediately? This is where we hit a fork in the road. You can stick with the raw, unconstrained power of a discrete x86 build, or you can opt for Apple's unified memory architecture. Apple's M4 chips merge system RAM and VRAM into one massive, unpartitioned pool. It offers incredibly streamlined efficiency, silent operation, and zero maintenance. For that route, the Mac Mini M4 Pro is the perfect out-of-the-box fallback. For $1,399, you're getting 24 gigabytes of unified memory, hitting 273 gigabytes per second of bandwidth. It's totally silent and wildly power efficient. It's built for users who prioritize a frictionless chatbot experience over maximum tokens per second. But hey, what if you're dealing with strict capital constraints? What if you want to get your foot in the door of local AI for under $300? Right now, the Intel Arc B580 is your absolute entry-level champion. For only $249, Intel's Battlemage architecture hands you 12 gigabytes of VRAM. It punches way above its weight for smaller 7 billion parameter models. The only catch? You do have to tolerate a pretty immature software stack compared to NVIDIA's established CUDA ecosystem. Jumping back to our primary 3090 build, though, the setup is actually remarkably fast. You just install Ubuntu, grab the latest NVIDIA driver, pull down Alamo with a single command, and run your model. It literally takes about 15 minutes to go from a pile of parts on your desk to having a fluid conversation with a high-parameter intelligence. And that brings us to the ultimate bottom line, 131.8 tokens per second for every $1,000 spent. Nothing else on the 2026 hardware market even comes close to touching the value metric of this specific 3090 blueprint. So I'll leave you with this thought. The AI hardware market is always moving, but time is money. If you hold off, waiting for next-generation hardware to eventually drop in price, will your compounding daily cloud subscription fees end up costing you more than simply taking control of your own intelligence this weekend?